Hello everyone, welcome to our video on measuring tools. So we've looked at a couple of things. How do you convert? How do you, know which unit to use? But this is how we actually use some of the instruments that we talked about before. So the first thing we're going to do is for measuring mass. And you can do mass in two different ways. The first one is with a digital scale, which I think is pretty easy, so I'm not really going to cover that one. But the other is a triple beam balance. That is this thing right here. Okay, so there's a few steps that we need to make sure of while we are getting our triple beam balance ready to go, okay? First is that everything is at 0, okay? So we have 3 of the different prongs. This one is for the tens. We have one for the hundreds, and we have, 1 through 10, then the tens, then the hundreds, okay? Now we are all set to 0, okay? Now I'm going to let it go for a moment because we need to make sure that it's actually balanced. And as it's kind of equaling out, you can see here the 0 and the line don't quite match up. So we're going to go ahead over here and do a little bit of adjustment. So give it a good twist, let it bounce, see if that fixed it at all, or if you need to do any tweaking still. Alright, just a tiny bit more the other way. You might have to do some trial and error on which direction to go, but you'll get there eventually. Now it's very important that this is actually balanced, because if it's not, then your measurement is going to be wrong pretty much, okay? So there we go. We're right about at 0. That's looking good. So we're going to just take this little cube and I'm just going to figure out what its mass is, okay? As you can see, this bumped up, so we are not balanced yet. We're going to start here with the single digits. Okay, that didn't change anything. So we're going to go ahead and add 10 over here. Okay, still no. I'm actually going to go ahead and add another 10. Nothing. 10. Nothing. 10. 10. Whoop, okay. So, because it was not balanced at the 40, but it went down on the 50, go back to the 40. Now we need to use this guy to equal it out. Alright, looks like we are just about there. Awesome. So that tells you that we are balanced. So, what is the final mass of this block? Okay, so what we're going to do, we're going to add each of the beams up. So we have 40 back here, nothing here, this is a 0, plus 4.1. Okay, so our final mass on this block is 44.1 grams. And there you go. Hopefully if you use a digital scale, it will do a very similar number. And if not, then maybe you need to do some recalibration and remeasuring. There you go. That's the triple beam balance. Alright, this next thing that we're doing here is how to measure the width of something, or distance, okay? There are 2 methods that we're going to use with this one. First is the meter stick, and the other is the caliper. So this is what a caliper looks like, okay? So we're going to use our same object. Make sure that you line it up with the 0. There we go. And then you follow. Where does it meet? Okay. So it looks like this guy is about 2.6 centimeters wide. Okay. Let's see if this guy agrees. Now, you need to make sure that it's lined up with a 0, because if it's over here, it's like, look, it's 10 centimeters, right? Well, no, not really. It might meet up with the 10, but this is all just not part of it, right? So if you do something like this, then you have to subtract the 7.5 from the 10. So maybe more like 2.5 rather than 2.6, but it's a pretty small distance there, right? Okay, next up we have the caliper. This thing is great for measuring things that are kind of on the small side, okay? See this? So what you're going to do, you are going to take your object and you're going to basically clamp it right in between there. What's also pretty cool is once you do that, as long as you don't move it, it still maintains the distance that your thing is at, okay? So you'll see here, how in the world do we read this, okay? Well, here's our 0, but that's not really this 0 here, right? but it tells you, see, your 0 is actually right here. So the 0 lines up with the spot that tells you what the distance is. So 2.6, which is exactly what we measured with the meter stick. So if you get two different distances, I know I said 2.5 at one point, but 2.5, 2.6, really, really close together. But if they're wildly different, 2.5 and 25 centimeters, probably need to do a little bit of remeasuring. There you go. That is the meter stick and the caliper for measuring distance. All right, the last thing that we need to measure is volume. All right, and one of the easiest ways to do this, and it's great with things like this, that's pretty easy. It's an easy geometric thing we have a formula for, is just to calculate it. So we got our caliper back out. I know we already did this, but here you go. Just a demonstration. All right, 2.6 by 2.6 by 2.6. Okay. I think that one is pretty obvious. 2.6 times 2.6 times 2.6. There you go. You can just go ahead and do that math, and that's your volume. There you go. All right, the next method that you can use if you need to measure the volume of something that's not really as super easy, say perhaps like a marble, and it's pretty small, is through a graduated cylinder. So a graduated cylinder measures volume. You can go ahead and put some liquid in there. I put 10 milliliters of water in here, and then you just drop your object in. Okay, let it settle. And the amount of water, or the total volume that is changed, is the volume of your object. So we had 10 milliliters, now this is reading 12 milliliters. So go ahead and subtract that 10 from that 12, and our marble is 2 millimeters. Easy peasy. All right, this last method is kind of if you have more than one thing going on, more than one issue with your thing. So we know this guy we can measure just by calculating the volume, but maybe that's not what we want to do. Let's use the graduated cylinder. Oh, okay. Well, that's not really going to work out. So, here's what we can do. We have this thing called a water displacement container. Looks a little weird, right? It's just a cup with a hole in the side, okay? And it's kind of using the same idea that the graduated cylinder does, okay? The water will go up when another object is added to it, and this is much larger. See, you can definitely put that guy in there. But we're going to fill this up all the way. Okay, as you can see, there's more water in there than it can really handle, so it's just draining out the little side. We're going to wait until it's done draining out the side. All right, looks like we're right about there. Okay, so then I think we could agree that this cup is as full as it could possibly be without anything else going into it, right? If we put any drop of water, that's going to come out the spout, right? All right, so we are going to take our graduated cylinder from before, going to put it right under the spout, okay? So that if anything goes in, it'll catch that water, right? And drop this guy in. Here we go. And there we go. Okay. Wow, that's quite a bit of water, huh? So, this water is the amount of space in here that was replaced with the block. Okay? So, this amount of water should be equal to the same volume as the block that's in here. Let's take this down a little bit, get our measurements. And looks like we are right about at 19 milliliters. Might be a little hard to see there on the camera, but 19 milliliters. Now, this isn't as accurate as the calculating method, but it's still, if it's a larger thing, it can give us a little bit more accurate of a reading. We know that water has some, some properties that make it stick to itself, and there's, maybe a little bit of water still dripping out the front, so it does take a little while. But if you have something huge that you need a pretty okay method to determine how big it is, this is a pretty good way to go. Okay, so that is water displacement.